Based on a survey, 36% of likely voters would be willing to vote by internet instead of the in-person traditional method of voting. For each of the following, assume that 17 likely voters are randomly selected. Complete parts A through C below. First question, before we get into the first question, let's identify what is the probability and what represents the number of trials. So, you can see here that the probability is 36%. So, we're going to say that P is going to equal 0.36. And then how many voters are randomly selected are 17. So therefore, we know that N is going to equal 17. Now the first question is asking us, what is the probability that exactly 14 of those selected would do internet voting? So we're looking at exactly 13. So recall that this is the same thing as finding the probability of when X is equal to 14. So we're going to click Stat, highlight Calculators, and select Binomial. We're going to enter the number of trials, which is 17, and we know that the probability of success is 0.36. And then what is the probability that exactly 14 of those selected would do internet voting? So we're trying to find the probability of exactly 14, where the probability of X is equal to 14, and then we're going to select Compute. So now, opening up StatCrunch, we're going to go ahead and put in our values, which is N is equal to 17 and P is equal to 36. We'll go to Stat, Calculators, select Binomial. We know that the number of trials is 17. We know the probability is 0.36. And we have exactly 14. So we should have equals and then the number 14. So now you can see what our probability is. And in this question, they want us to round it to 5 decimal places. So therefore, we're going to round up here and make this point 0.00011. So let's just copy this so we can confirm that. So therefore, there is our probability. So we would say the probability that exactly 14 of those selected would do internet voting is 0.00011 rounded to 5 decimal places. Okay, next, we're going to move to part B. For part B, it says if 14 of the selected voters would do internet voting, is 14 significantly high? Why or why not? So again, we need to make sure that we understand what this means when it says 14 is significantly high. That means that we're looking at, is it the probability of 14 or more? Okay, or another way of saying this is that the probability that it's at least 14, or the probability that X is greater than or equal to 14. So here, again, we're going to select Stat, highlight Calculators, and then select Binomial. So we're just going to pull up our StatCrunch again, since we already had that information in there. And then, again, we're looking at the probability of X being greater than or equal to 14. So let's go ahead and open that up. So the only thing we need to do now is we just need to change this symbol to be greater than or equal to. And so here, if we want to round that to 5 decimal places, we're going to have 0.00012. So let's go ahead and copy that. So there is our probability with at least 14. And so we would say the following. We would say that the probability of at least 14 of those selected would do internet voting is 0.00012. And again, that's rounded to 5 decimal places. Now let's take a look at the next part. It says having X successes among N trials is a significantly high number of successes if the probability of X or more successes is 0.05 or less. And that is, X is significantly high number of successes if the probability of X or more is less than or equal to 0.05. Well, we found that the probability of 14 or more gave us this particular probability. So to determine if the result is significantly high or not, we want to compare the probability of 0.00012 to 0.05. And we can see here that the probability of 0.00012 is less than or equal to 0.05. And so therefore, because of that, we would say yes, 14 would be significantly high because the probability of 14 or more gives us 0.0012, which tells us that the probability is low. Now in part C, it says, find the probability that at least one of the selected likely voters would do internet voting. So now we're talking about at least one. So if we're looking for the probability of at least one, that's the same thing as saying the probability of X being greater than or equal to 1, or 1 or more. So again, we're going to follow the same procedure, but the only thing now is that we're going to put in the fact that X is going to be greater than or equal to 1 in the stack crunch. So let's go ahead and do that. So we already have N equals 17. We already know what our probability is, and now it's going to be greater than or equal to 1, and then we're going to select compute. And so now let's take a look at that probability. Now again, we're rounding this to 5 decimal places according to the question. Okay, and so if you take a look at the probability here, we have to 5 decimal places, we have 0.99949. So the probability of at least one of those selected would do internet voting is 0.999. So in this question, they're actually asking for you to round it to 3 decimal places. So rounding it to 3 decimal places, we get 0.999, and therefore that represents our solution for part C.